Question 77. A piece of wood that is 4.5 feet long is cut into two pieces of different lengths. The shorter piece has a length of x feet. Which inequality expresses all possible values of x? So for these types of problems, honestly, at least for this problem, I wanted you to use logic, and we're going to eliminate every choice here, or at least the wrong choices, just by using plain logic and little to no math. So first I want to start off with what seems obvious to me at least, choice B. This choice is saying that the variable x, which is the length of the shorter piece of wood, is between 0 and 2 1/4. Now you might be asking, why doesn't that make sense? Well, first of all, it can't be 2 1/4 because, for example, if this is the shorter piece, it can't be 2 1/4 because the other piece also has to be 2 1/4 then. Because remember, it has a total length of 4.5. Now this does not make sense because we can't call this piece longer when it's literally the same length as supposedly the shorter piece. So we can eliminate choice B just based off of that. Also, keep in mind, if we have two pieces of different lengths, that means that we have two tangible objects. And we can't say that the length of one is 0 feet because, well, it doesn't exist. We just didn't cut the wood at that point. Next, what I want to eliminate is choice C and D, to be honest, at the same time. And obviously that means our answer will be A. But let me first explain why C and D don't make sense to me. So C and D are basically saying if it can be any number greater than 2 1/4. So let's say 3. Let's say the shorter piece is 3 feet. That means the longer piece has to be 1.5 feet. Now, I don't know about you, but that doesn't make sense. How can the longer piece of wood have a shorter measure? That doesn't make sense. So we can't have a number greater than 2 1/4. And it can't be 2 1/4 either, because then the other piece would also be 2 1/4, as I explained up here. So we can eliminate C and D because they include numbers above and greater than 2 1/4 in their range. And that leaves us with choice A. Just like that, I reasoned it out. Obviously, you don't want to think, or like you don't want to be saying as much as I did. This should be something that you think of as soon as you see the question. Now, question 78. This is a fun question. And for this, we're being asked, what is the area in square units of the shaded region shown in the figure above? So, just immediately, I noticed that we have a triangle. This triangle goes, well, at least has two sides that are on the x and y axes. And we have something like that. Now, something else I want you to notice is that in that triangle, we have another triangle. Interesting. And we have this weird trapezoid figure right here. But that's not important, right now at least. So we notice that we have two triangles, and we know that because we're being asked to find the area, we know that the area of a triangle is 1/2 times base times height. Now, since it's asking to find the shaded region, I want to try to find what the area of this could potentially be. Now, let me tell you, it is kind of difficult to find that area without a shortcut. And because it's a weird shape, isn't it? It's not even like your regular trapezoid. It's weird. So what I would do here is I would actually look at the area of this big blue triangle over here, find the area of that, and then find the area of the green triangle right here. And then if I subtract the area of the blue triangle minus the area of the green triangle, I should get the area right here. Right exactly here. So that's exactly what we're going to do. So here, let's find the area of the blue triangle. Area of blue triangle. So we know that it is 1/2 times base. It doesn't matter what you call the base and height here because it really doesn't. You're just multiplying them. Yeah. So 1/2 times 20 times 20. Cool. And that is equal to 20 times 20 is 400 times 1/2 is 200. And it doesn't say, or it says square units. So we're gonna call this units squared, okay? And now we're gonna find the area of the green triangle. That is equal to 1/2 times 10 we see here times 15. And that right here, 10 times 15 is 150 times 1/2 is 75. 75 units squared. Now notice something I find very funny is that the exam is trying to trick you. You did get 200 here and 75 here, and these unironically end up being answer choices. Don't eliminate them just yet, just in case something does happen where we end up with those numbers as our answers. But for now, all we have to do is just do 200 minus 75 to get 125 units squared. And this should be the area not covered by the green square in the green triangle, in the blue triangle. So our answer choice is choice F. And let's see, that was question 78. 78 is F. Yep, 125. Cool. All right, sorry for the cut there, but we will continue. So, question 79, the last question in this set. Yesterday in Centerville, the highest Fahrenheit temperature, F, was 86 degrees, and the lowest temperature was 68 degrees. What was the difference between these temperatures in degrees Celsius, C? So first, difference should automatically tell you subtraction. Keyword right there, you should already know that. So what I'm going to do first is I'm going to convert 86 degrees Fahrenheit into Celsius, and then I'll convert 68 degrees Fahrenheit into Celsius. And then after, I'll just find the difference, and that should hopefully be one of these four answers right here. So let's do that. So we're going to take this equation. I'm just going to copy it over right here. Copy that equation over here so it's easier for us to keep track. So first we have 86 degrees. We're going to plug it into the problem, and we're going to solve algebraically. This is something you want to practice because the test does ask you for this quite a bit. So we have 6 minus 2 is 4, 8 minus 3 is 5, is equal to 9 over 5c. And now what we're going to do is we're going to divide by 9 over 5, so we have c just on the right side. And that just means multiply by 5 over 9. So 5 over 9 times 5 over 9. This is not the fun calculation. We get 270 over 9, and that you should know is 30. So we're getting that 30 is equal to c, or c is equal to 30. Well, actually, don't get too caught up with that just yet, because this is just the Celsius equivalent of 86 degrees. So the other one, 68 degrees, the low, we're going to do the same exact thing for, except we're going to plug in 68 instead. And once again, we are solving for that variable in our problem. 36, so we're going to, just like before, we're going to multiply by 5 over 9. I'll just do that in my head because you got the idea before. 36 times 5 is 180, divided by 9 is 20. So the other c is equal to 20. So now all we have to do is, because the problem asks for the difference in Celsius, we're just going to do 30 minus 20 is equal to 10. 10 degrees Celsius. That is the answer, as you can see here. So choice A, I believe was A. Perfect.